Hello nerds! Once again, we're back with the Pacathon videos. Today we are going to look at the Pacathon project sort of as a whole and look at some of the different bits, and we're going to hopefully write some code as well. I want this video to be a great intro to actually understanding what to do. Alright, so I have just opened IntelliJ IDEA, my preferred Java editor, and I have Pacathon, the project, cloned over here. If you're not sure how to get all of this set up, then you should watch the previous video. But for now, we're going to open up our Pacathon project, which we can find in our desktop right here. And I'll trust that project, of course. Just trust me. Trust, it's fine. And we're going to see all of our README stuff get popped up and a couple other things. But I'm going to ignore that for now, especially since I'm still writing that at the time of this video. But we have a bunch of folders here, and we really only care about two of them. So if we go into the LWJGL folder, this terribly named one, we can go into the source, which is where all of our code is stored, and we can go all the way down the hierarchy into the actual runnable stuff. So this is the fancy code required to actually run everything with the GPU in mind. So if we click run here, or alternatively, if you are using any other editor, you can type Gradle W LWJGL run. We will see this code get run. And this is what, of course, starts our Pacman window, like we saw in the previous video. But there's one important bit of information here. I'm just going to quit this window because we don't need to see it again. I have isTraining false as the default, which means we're going to have this code get run. This code is the tournament-specific code that you don't really need to ever run. It's just what I'm going to run when I test everyone's models, but it's useful if you want to test how good your model's doing on the tournament benchmark. But the actual main code, the training code, is what you're interested in. So we're going to set this isTraining value to true. So now when we run this window, this desktop application, we'll see something slightly odd. We're going to see a bunch of Pacman windows at the same time, and they're going to be sort of automatically controlling themselves. You'll probably see some very mixed results here. You probably won't see this guy going around in circles like crazy. You'll probably see a lot of these people just rotating around in circles. These are your Pacman. You're going to train them, and you are going to hopefully make them super good by the end of this tournament. So where are these guys in code? Like how do we get there? I'm going to close out of this window for now. You can see that we've launched this main application here. So let's navigate over there. If you don't have navigation in your editor, you can find this file if you close everything and we go into the core section and of course the source code, and we have this main file here. That's what we just opened. This file is a little bit overwhelming if you try to look at it in full. So what we're going to do is we're going to minimize every single method except for this create neat method. So I've minimized create, I've minimized the save folder, reset, render, and dispose. Great. Now this file, or this method in itself, is also a little bit overwhelming, but you can see that this is just a special bit of code I've prepared for you in case you want to run it. The actual important bit is just this neat instantiation. All this is doing for you is setting up the neat. If you've been to the AI Society meetings in the past, you'll know that this is what you've been coding for the past few weeks. We've been trying to implement this genetic evolution algorithm, but we don't need to know the exact details of this implementation. We can sort of just trust it works in this case. And this creates a bunch of games. So in this case, we see 250 games. We only saw 8 in the window, but that's because there's only so much space on a screen. So we have this neat instance, but where are our Pacman? Well, we're going to jump between this main class, but we're also going to jump between this behavior class. So if we hop over to entity and then behavior, we can see this neat Pacman behavior. This is going to be the class you're in the most. You really have no good reason to be outside of this class. So 90% of your time will be spent here. You can see that we have a very, very primitive implementation right here. But let's walk through it. Let me scroll in so it's very easy to see. Alright, so this is, if I scroll to the top of the file, a behavior. So a behavior is just any method that returns either up, down, left, or right. And Pacman, of course, goes up, down, left, or right. If we scroll over to the actual implementation of that code, here's where we say we return up, down, left, or right. We see that we have some directional code where we figure out which direction is forward, which direction is left, right, and behind. And we call these quick helper methods to see if we can move in those directions, which means if Pacman is facing a wall, we would expect this can move forward method to return false. But if there's a space or a pellet, we might expect it to return true. Now we take these values we've just found and we plug them into the neural network. For Booleans, it's generally pretty easy to say true is 1 and false is 0. And you can see we throw those into the network and then take some output. Again, if you've been to the AI Society meetings, you'll recognize this code as figuring out which direction to go in afterwards. This is all not so complicated once you take a moment to read it, but I don't want to bore you too much with the implementation details. But one of the most important things here is setting the score of the client. So this is your fitness function, your reward function. If you modify this, you should definitely be modifying the score modifier, which is just an integer that we can add numbers to, say 10, 20. And if we add any number to this, that means the Pacman is doing really good. Okay, so we've kind of looked at this behavior class, but how does this actually work in the game itself? Like what correlates to what? I see all this code, but it's confusing. So if we go back into the terminal, and apparently our old window is still running, so let me just get rid of that. I'm going to run it again from scratch, and we've changed nothing, but I just want to see some things. I just want to see how everything works. We can see our Pacman over here. I'll just maximize this. All right. Well, we can see if we press Tab on our keyboard, we have a neural network. It has one bias input and 4 other inputs. And we can see that this corresponds to up, down, left, and right. So if we press Tab again, we can see that it's kind of going crazy in circles. So that's why we see this flashing. That's why the white flashes to black very quickly. So let's look at something a little easier. If we look over here at this neural network, we see that we have the bias up, down, left, and right. And we can see that since the Pacman's just facing up all the time, we can see that we can move left and right, but in no other direction. Makes sense. All right, but this isn't going anywhere. Our Pacman are never dying, for one, and they're not moving. So we need to encourage them to do something. I'm going to implement one of my very simple tricks of just killing off the Pacman if it starts to, or if it never collects any score for a long time. So what we'll do is we'll store 2 variables, a private integer for the number of updates since last score. And this starts out at 0 and it grows over time as Pacman doesn't collect any pellets. We can store another one called last score. And we can use this to detect if the score ever changes. Okay, so let's go back over here and I'll zoom in. Here's where we can add our special conditions. So if I check, and let me turn off completions here for a second. we can say int new score is equal to the current Pacman score. And we can get that by calling Pacman dot get maze level manager and then the score. This is the total score across all levels, even if Pacman dies and comes back. And then we can check if this new score is greater than the last score. If it is, then we should try and update the last score. And we should set the updates since the last score to 0. We should reset it. But if we ever end up in a situation where the number of updates since the last score is, say, greater than 60 updates per second times 10 seconds, so 10 seconds, we should kill off Pacman. So pacman.kill. And we'll just skip early. We'll say direction up, any random direction. That way none of the other code gets executed. Okay, what we've just done here is hopefully created a system where Pacman is encouraged to get more pellets, otherwise Pacman will die. We're a pretty cruel god here. So if we go into our terminal again, we can cancel all of the old stuff and run it again. And hopefully what we'll see is a couple of Pacman, and they'll be dying off if they don't collect any pellets. So let's see how it works. I'm just going to watch it for a second. And already we're seeing much better progress. You can see that as Pacman tiles die off, or Pacman games die off, the screen kind of goes black, and that's because those games go away once the Pacman dies. And only the ones that have a really good score are left over. And you can see with just some time, the Pacman is getting some score. It's getting, say, 100 points or 500 points. It's not bad. It's not great, because right now there's no ghosts, and it's really just trying to collect some pellets. Hopefully, you guys will be able to implement more systems like, say, pathfinding or ghost avoidance or any sort of special system, so that way you can create the best possible Pacman and win the prize. Alright, I've been yapping for way too long, so hopefully this gets you a really strong start on what you should be doing and what you should be modifying. So to give a really quick overview, most of your time should be spent in this neat Pacman behavior class. All your code can go in here, of course, and every once in a while you might hop over to the desktop launcher application we opened at the start, just to flip around between training and testing in the tournament. And of course we can have our main class if you want to load up old stuff or modify this new stuff. And I'm going to go over this a little bit more in the next video, but for now, hopefully you can understand what this behavior class is for, and how every Pacman gets their own behavior. And, good luck modifying this. I hope to see some really cool stuff.